Okay, welcome ladies and gentlemen. So this video is going to teach us how to do the equation of a quadratic function, given information about that function. So, determine the equation of the quadratics that have undergone the following transformations. We need to go up 5, to the left 7, and a stretch of 6. What we really need to keep in mind is this is just a game of determining all the values of a, h, and k. So, if we're going to go up 5, that means my k value equals positive 5. If I'm going to go left 7, that means that my h value is actually going to work out to be plus 7, and my stretch is going to be an a value of 6. So an answer to this is going to look like x plus 7, so that's going to move me to 7 to the left. Don't forget your squared, otherwise it's not a quadratic. It's going to be plus 5 to give me my up 5, and for a vertical stretch, I'm going to need a 6 for my a value. Same thing's going to happen here. So again, I'm going to start with this right 20. So x minus 20 squared is giving me my right 20. My down 13 is negative 13. And a compression of 1/3 is going to be given by 1 over 3. Oh, I'm sorry, a compression of 3 means a multiple of 1/3. Now a maximum of negative 2, that's kind of neat. If it's a maximum, we know that it's going to open down. What that means is that your a value must be negative, and this must be your k value from your vertex, because it's my maximum value. So what I know is that this quadratic is going to look something like this. Okay? Now, notice that the h value is 0 in this. It didn't have to be. This too would be a fine answer. It's just they didn't tell me that it went over a stretch of 6. So maybe that isn't a good answer if it says that it's only undergone the following transformations. So if only these transformations have occurred, then this is the only answer that we could have, and that would make sense to me. Okay. Determine the equation of a quadratic shown on the graph below. So the game again is to figure out y equals a x minus h squared plus k. Any way we can. And there's sometimes different ways of doing that. The vertex is always a great place to start. So this is going to be 6 comma negative 7. So that's going to give me an h value, and that's going to give me my k value. So I know that I'm going to start off with y equals a x minus 6, because it's to the right, squared, minus 7 because it's down 7. So that's all well and good, but I don't know my a value yet. There's a couple of ways to get that. One way is to sort of figure out the step pattern if you can. I go over 1, I seem to go up 1. I go over 2, I seem to go up 4. I go over 3, and I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's looking to me like it has a step pattern of over x squared, so over x, up x squared, which if that's the step pattern, the a value equals 1, which means that my final answer would be y equals 1, x minus 6 squared minus 7, or more compactly, we'll get rid of that 1 and we'll just leave it blank out there. And that would be our final answer. However, you want to put that 1 in, that's nothing wrong with that. Now I'd like to call your attention to something just for a moment, because it's not going to always be so easy to do that step pattern. Let's go back to this point. Y equals a x minus 6 squared minus 7. And remember, we got that by looking at the vertex. So we don't know the a value. Here's another way of doing it. Find any other point on this curve other than the vertex. I don't care what point, just some point that you're fairly accurate, that you can read off the coordinates. So this point would be 4 comma 1, 2, 3, 4 comma negative 3. So I'm going to choose the point 4 comma negative 3. Now what does that mean? That means that when x equals 4, y equals negative 3. Now that's going to be very useful, because if I put in this value of 4 for x and this value of negative 3 for y, I can solve for a. So what we're going to have is negative 3 equals a. 4 minus 6 squared minus 7. So order of operation has to occur, so I got negative 3 equals a minus 2 squared minus 7. I'm going to do negative 2 squared, which is 4. Negative 3 equals 4a minus 7. Put the 4 in front because that's normally where we put it. Bring the 7 over to the other side. Negative 3 plus 7 equals 4a. 4 equals 4a. Divide both sides by 4, and we end up with 1 equals a, which is what we came up with by looking at the step pattern. Both ways work. Be able to do both. Last example. All right, so again, it's a game of figuring out the values of h and k. Let's look at my vertex. It's going to be 1, 2, and then it's going to be negative 9. That's my h. That's my k. So a minus, so it's x to the right, so it's minus 2 squared, don't forget that squared, minus 9. I don't know my a value yet. Over 1, it's definitely not up 1. Over 1, up 1, 2, 3, maybe. Over 1, up 1, 2, 3, 4, maybe. Over 2, it's too hard for me to tell. So I'm going to choose any point on this curve that I'm fairly confident with its coordinates. Let's do this one. So that looks like 1 comma negative 5. So I'm going to use the point 1 comma negative 5. That means that when x equals 1, y equals negative 5. Now listen, when you're doing your homework, if you want to get these right, write out everything I'm doing. Don't shortcut it. Don't try to do things in your head. Follow the pattern. You'll remember the pattern, you'll remember the logic, and you'll be able to do the questions on a test. So let's put in what we get. Negative 5. That's for the y, equals a. Don't know what that is. 1 is for the x. Minus 2 squared minus 9. 1 minus 2 is negative 1. Squared. Negative 1 squared is 1. I don't have to put the 1 in front of the a. That's what just 1a means. Take the 9 over to the other side. A equals 4. That's important. That means my final answer is y equals 4, x minus 2 squared minus 9. Life is grand. That's the end of that sheet. Okay, so what are you supposed to do now? Well, why don't you practice that? So the next sheet is quadratic practice and problem solving. It is two-sided, so you can do that, and I'll post solutions for that in a minute. And then following that, you can do your quadratic functions progress check. That's the end of this workbook for this unit, and we may have some textbook questions after that, and we'll go from there.